To those who are online, am I audible?
Sir.
Okay. Yeah, solve this. Solve this. How did the question change? Oh, this one only I gave up. Okay, I pressed something. That's fine. Okay, solve this. Here. எழுதறா 20 30 20 80 20 இது I3. listen. If I take the points to be A, B, C, D, E, and F, right? Then, if I take the loop, 2 ampere, I don't think. So, if I take the loop to be A, B, C, F, A. So, when I take the loop as A, B, C, F, A, when I go from A to B, we are walking from higher to lower potential. So, it is minus 30 I1. When you're going from B to C, there is no resistor, so nothing. When you go from C to F, it will be plus 20 because you're going from lower to higher potential. Lower to higher is plus. Which one? This one. Lower to higher is you're gaining energy, so plus. எது சொல்றீங்க இதுவா இங்கயா ஆமா I didn't write for that. No, see, minus 30 I1 plus 20 minus 20 into I3 is equal to 0. Yeah, got it. Similarly, if I take the loops FC, DEF, so if I take the loops FC, DEF, when I go from F to C, you're walking against the direction of current. Against means negative. Sorry, positive. You have 20 I3, 20 I3. You're walking up from higher to lower potential across the cell. So it is minus 20, right? From C to D, there is nothing. From D to E, you're walking against the current. So plus 20 I2 minus 80 is equal to 0. So what you get is 20 I3 plus 20 I2 minus 100 is equal to 0. Am I clear? Okay. So what will happen here is 20, 20, and this will get cancelled 5 times. So I3 plus I2 is equal to 5. Similarly, from this equation, if I write, I'll cancel the zeros. So we will get I1 plus I3 is equal to 2. You will get I1 plus I3 is equal to 2. But if you see, you have 3 unknowns, but only 2 equations. Now you can ask me a question. If you take AB, DEA, you will get the third loop, write the equation, but it will be the sum of the first and the second. Yes. So what we need to do here is we need to apply the Kirchhoff's current law. So what does it state? If you observe here, at the junction F, right, at the junction F, current is entering it, which is I3. So I3 is equal to I1 plus I2. Right? I3 is equal to I1 plus I2. Okay, I3 is equal. Kirchhoff's current law. I3 is entering the junction. Current entering the junction is equal to the sum of the currents leaving the junction. I1 and I2 are leaving the junction. So that is the answer. Okay. So take this and substitute in this one and this one, so that you will get I1 plus I2 means I1 plus 2I2 is equal to 5. Here what is the answer? I1 plus, sorry, 2I1 I2 is equal to 2. Right? So take this and multiply it with 2. So what will you get? 2I1 plus 4I2 is equal to 10. Subtract both, they get cancelled. Minus 3I2 is equal to minus 8. So I2 will be equal to 8 by 3. So when I2 is 8 by 3, then what will be the value of I1? Substitute it back here. So I1 plus 16 by 3 is equal to 5. So I1 will be equal to 5 minus 16 by 3, it will be minus 1 by 3 ampere. So the meaning of this negative sign is that the direction of current that we assumed is opposite to the original direction. So I1 is not going in this direction, it is going in the reverse. This is the value of I1, sorry. This is I2. Yeah. For I2, the direction that we assumed is reverse. That is the meaning. Got it? I hope it is clear, no? Dua. What about? This one. I1 plus I3. Oh, it is 3I1 plus 2I. Oh, sorry. Whole thing is changed. So 3I1 plus 2I3. Sorry, 3I1 plus 2I3. Then what is that you are getting if you solve with this? Then the whole thing will be wrong. I didn't check that. So 3I1 plus 2I3 is equal to 2. Then you need to take this and substitute it and then solve. I don't have answer in. What is that you are getting? We'll go with the common answer. I2 has 3. Anyone else with that answer? See the I1 plus 2I2 is equal to 5. So I1 plus 2I2 is 5. 3I1 plus 2I3 is equal to 2. So take this and substitute it here. And then I1 plus I2 substitute 100. You substitute and solve, tell me what is the answer. Seven by 6. Which one is 7 by 6? I1 is coming out as 7 by 6. What about I2? Engada? Enga I1 plus 2I2. Edua. I1, see, I1, I2 plus I3 is 5. Engada? I2 plus I3 is 5. But in the place of I3, if I take this I1 plus I2 and substitute, then I'll have I1 plus I2 is getting added to another I2, no? That is why 2I2. I1 is minus 3 by 4, 23 by 8. I think that's what the previous batch also told. Minus 3 by 4 and 23 by 8. They told the 23 alone, I don't remember. Minus 3 by 4 is right. That's what they told. But did you understand how to solve this problem? Right? It's basically linear equations in two variables. Okay. So having said that, I want you to solve the next one. I myself wrote the answer. Treat it as ohm. There is a mistake. Clear? It is similar to the problem that we did yesterday. Okay, do this fast. You can do it on your own. It's a simple problem. Do it fast. 6.5. Correct. See, it is similar to the previous problem that we did yesterday. You will have I is equal to E divided by capital R plus small r. That's an formula. Apply that, you will get the answer. Okay. See, this problem I'm not doing because I did it yesterday. I will solve some more problems from the sheet. It's good. Correct. Internal resistance is 1 ohm. EMF is 13 by 2, 6.5. So EMF is 6.5. Internal resistance is 1 ohm. To solve this problem, you can refer the problem that I solved yesterday. The third problem that I solved yesterday. Formula that we are supposed to use is I is equal to E divided by capital R plus small r. So I is given in the problem. Once it is 0.5, second time it is 0.25. So you need to use this formula twice. Similarly, EMF in the first case is E. The second case is also E. Capital R in the first case is 12. Capital R in the second case is 25. Okay. Clear? Yeah. So listen. So there is a problem like this. See, Okay, all that we need to do is find the value of BC minus BB. Okay, so try this problem. சொல்றா அவ்வளவுதான். So this is a part of the circuit. Okay, the portion that they have shown here is a part of some circuit. So if that is the case, they are asking what is the potential difference between the point C and D. So tell me how to solve this problem. How to solve? Okay, wait. Actually, there is one more data given here. This is 4 ampere. Yeah. So you use whatever you want, KVL, KCL, whatever logic you want, you use. Tell me how you are supposed to approach. It's not given. It's not given. I don't think that is needed, but let's try and see. Okay. So tell me how to do. See. Now, we have this kind of a circuit where this is a part of some circuit. Our job is to find the value of the potential difference between the points C and D, right? So whenever you have an open circuit, we know how we are supposed to apply Kirchhoff's voltage law. How will you do? You'll start from a particular point with a particular potential. You lose at some points, you'll gain at some points, and you land at the last point with that value of potential, right? So here, if you observe, if I start at C, I can write it as VC, right? I'm going towards B, right? So across the 1 ohm resistor, I'm going against the current. So plus 1 into 5. 1 is the resistance, 5 is the current, right? Across the cell, I'm going from lower to higher, plus 12, right? So across this resistor, I don't know in which direction I'm going. So I'll take the current here to be I, right? So what is going to be the value? It is going to be plus 2I. Here, what is going to be the value of potential? Minus 3. And across this resistor, it will be minus 4 into 2. everything put together should be equal to VB. You're walking in the direction of current. I told random direction. I told you I don't know when I assumed itself. Okay. So the only confidence I have is if I'm right, I'll get the value of I as positive. If not, math will take care of it. I didn't worry about it. So did you understand how I wrote the equation? I started with VC, I went in this direction and I landed at VB. This is how we derived the relation between terminal potential and EMF. V is equal to E minus IR. This is the logic. Okay. So let this be simplified. VC plus this is 5, 5 plus 12, 17, 17 minus 3, 14, 14 minus 8 is 6. So VC plus 2I minus 6 is equal to VB. So it is telling me that if you know the value of I, I'll be able to solve this problem. What I'll do is I'll take this junction. So at the junction, what is happening is 2 is going in this direction, 4 is coming in this direction. 1 minute. So I is going in this direction according to what I assumed. If you observe, all the currents are away. So sum of all the currents, I plus 2 plus 4 should be equal to how much? 0. Because there is no current entering the junction according to the way I assumed. So what is the value of I? Minus 6. Take this and substitute it here. What will be the answer? This will be minus 6. Plus 6. Oh, this plus 6. So then it should be VC, then it should be 0. I'm not sure if that is the answer, but let me check. The 0 illa. It's given as that's the answer. Wait now. I'll come again. See. Thing is, if you bring the minus 6 and substitute it here, so you will have VC minus 12 plus 6 is equal to VB. Bring it this side. So VC minus VB is equal to minus 12 plus 6 is 6. So 6 is the answer. Okay. That is not a part of the equation I considered. No, we don't need anything to do with this. Why they gave only to confuse you. You have nothing to do there. In this problem, there are two unknowns. One is VC minus VP, and the second is the amount of current that is flowing through this particular branch. Because if you take the linear part alone, whenever you need to calculate the potential difference between 2 points for an open circuit, I repeat it, for an open circuit, you start from a particular point, you apply the Kirchhoff's voltage law, and you write the potential of the last point on the right hand side. This I've taught it. This I've taught you, right? So when you do this, after I simplify this equation, I understood that for me to get VC minus VB, I need to know the value of the current that is assumed. So to find that value of current, what they did is they helped me by giving the values of currents across the different two branches from that junction. So when I drew the free body diagram of it, right, I understood that the current is going in the left hand side. This side it is 2, this side it is 4. Right. So sum of all the currents put together is 0. If you want, you can solve the problem in reverse and see. You can take the value of I to be in this direction, solve and see, you will still get the same answer. Which is I1? Then you didn't understand that. What did I say? Kirchhoff's current law says that the sum of the currents entering the junction, the sum of the currents entering the junction is equal to the sum of the currents leaving the junction. Here all the currents are leaving the junction. That is why I plus 2 plus 4 is one side is equal to how much is the current entering the junction in this case? Nothing. That is why I put a 0. So what I am telling through this problem is, whenever you have an unknown with respect to current, you can consider it whichever side you want. Mathematics will take care. For example, here I got -6. What is the meaning of it? The direction that I assumed is wrong. Okay. The direction I assumed is wrong. That is obvious because 12 volt has a positive potential this side. Current will obviously flow in this direction only. Right? Am I clear with this? So 6 and 1 option 1 da koduthiru. 6 is right. Okay. So there is another problem like this. It says there is a cell which is connected across a resistor R1 here, R2 here. Similarly, R1, R2, R1, R2, and so on. Meaning this R1 and R2 is repeating itself infinite number of times. So here also you have R1, here also you have R1, here also you have R1. So R1, R1 and R1, this is E. Okay. So remember, R1 is given as 1 ohm, R2 is given as 4 ohm, right? All that we need to find is the equivalent resistance between the points A and B. Okay. So you need to find the equivalent resistance between the points A and B. Okay. So this is a problem where a particular branch is repeating itself. Which branch is repeating? R1, R2, R1, R1, R2, R1, R1, R2, R1. It is an infinite set. So tell me one thing. If I find the equivalent resistance of this, if I call it as R effective, okay? If I say that the equivalent resistance of this complete network is R effective, can I say that the equivalent resistance of this part is also R effective? Because from that infinite set, what I did is I left one box for my reference. I took the remaining to be the infinite set. So if I subtract 1 from infinity, it is not going to make any difference. So listen to this carefully. If I take the equivalent resistance of the whole network starting from point A till infinity, how much is the equivalent resistance? It is R effective. So what I can do is, if I take the first branch and keep it for myself, I can say that from here also the value of equivalent resistance will still be R effective. So how I can redraw the circuit is, observe. So what I did is I converted an infinite set resistor network into a finite set resistor network. So what is going to be this value? This is 1, this is 4, and this is 1. Now tell me one thing. How is this R effective and 4 connected? They both are parallel. So when they both are in parallel, what is going to be the equivalent resistance? R effective into 4 divided by R effective plus 4. So after you draw that, this equivalent resistance is connected to this 1 and 1 in what way? Series. So what you will do is you will put the plus 2 here. Why did I put plus 2? Because plus 1 and plus 1. It is going to be plus 2. Now, this whole thing is still equal to R effective. because that is the equivalent resistance for infinite set. So what are you getting? You will have this equation. When you solve this, you will get a quadratic equation. Then you need to solve for the answer that will give you the result. So we'll do and see. 4 times, I'll call it as R, plus 2 times R plus 8 is equal to R square plus 4R. R square plus 4R. So 4R and 4R get cancelled. You have R square minus 2R plus 8 is equal to 0. Not plus 8, minus 8 is equal to 0. So since you need to get minus 8, I'll write minus 4 plus 2. So this implies R minus 4, what happened? R minus 4 into R minus 4 into R plus 2 is a 0. So what will be the value of R? 4 or minus 2. So since minus 2 is not accepted, R effective will be 4. That's the answer. Okay. So this kind of a problem is there in your textbook also. Only difference is instead of R1, R2, R1, you have everything to be R. Current divider. There is one more problem based on. See, this you can definitely do it. There is a problem like this. See, listen. The value of R in this circuit is to be found. What is the value of R? If you observe the circuit, what has happened is there are both the ends of the circuit is grounded. Right? Then you have one cell which is of 25 volt. There are 2 resistors, out of which one is 2 ohm and the second is 8 ohm. And you have one unknown resistor, capital R. Through this network or through this circuit, there is a current of 2 ampere flowing. All that you need is find the value of capital R. So how to proceed? Potential of this point is 0. Potential of this point is also 0. So start from there and equate it. Start writing the Kirchhoff's current law and then solve it. Option A. 5-way illa option. See, this is A, this is B. Okay. Now see, how should I start? VA So first I'll write VA, then what should I write? Plus 25 minus 2 into 2, which is 4, minus 2 capital R minus 16 is equal to VB. And remember, VA and VB have 0 potential. So 25 minus 4, 21, 25 minus 16, 5. So 2R is equal to 5. R will be equal to 2.5 ohm. That's the answer. Okay. So 2R is 5 and R is equal to 2.5. Okay. சொல்றா KVL KVL தான் யூஸ் பண்ணியிருக்கேன்டா. அது KVL தான் நாங்க யூஸ் பண்ணோம். இதுதான்டா KVL. KVL. Current இருந்தா why would I write potential? Correct? I don't remember telling current. Did I say? I don't remember. See, there is a problem like this. It is very simple. Observe. There are 4 resistors of equal value which are connected in this kind of a shape. Okay. So all that we need to find is find the equivalent resistance between the points R, A, B. If you observe the problem, we can solve it in one step. What is the answer? Listen, I've told one point many times. If you are able to apply that, you will get the answer in one step. If 2 points are connected without any resistor between them, they both are said to be at the same potential. Meaning, this is AB, no? What will happen in these kind of problems? You will concentrate only on the inner part. Look at the outer part. Outer part is completely a wire. So A is fixed, but B is there, no? From A to B, understand, if this point is B, this is also B, this is also B, this is also B. Why is it so? Because they are connected with the help of a wire. Everything is at the same potential, right? When that is the scenario, between A to B, you have 1, 2, 3, 4 resistors connected in parallel. So 1, 2, 3, and a 4, each of value R. So what will be the equivalent resistance? R by 4. That's it. Did you understand? That's it. One was added with resistor. We'll solve it. We'll create a problem. Where do you want me to put? Between which 2 points? Top? Here, shall I put top? So he's saying, what if the problem was not like this? between any two points on the circumference, there was a resistor. We'll try and see. Shall I proceed? Listen. Suppose the problem was like this, AB. Okay. Now you need to find the equivalent resistance between the points A and B. Same, right? Tell me, if this is B, this is also going to be B, this will be B, and this will also be B. So how many B's do we have? Right. You have 1, 2, 3, 4. You have 4 B's. One, I'll take it here from A to B. Let's see. This I'll call it as 1, 2, 3, and 4. Okay. So between A to B, the first resistor is connected. Remember, all are of equal value only, but for understanding, I'm writing them as 1, 2, and 3. Between the same A to B, there is a second resistor connected. Right? So this I'll call it as 2. Between the same A and B, what is connected? Between the same A to B, what else is connected? There is 4 that is connected. Okay. So this is also done. So between the same A to B, okay. I'll come to this. Yeah. Between the same A to B, what is there? 3. So all the 4 are again connected in parallel. Then what about this one? So the only difference here is, what will happen is, though you have connected a resistor here, since this side and this side is bringing the potential of the points to be the same, this will be ineffective. What do I mean by ineffective? It will become a short circuit. Why is it so? Because if the potential of this point is 5 volt, what will be the potential of this point? 5. What will be the potential of this point? 5. From here, what will be the potential of this point? 5. When 5 and 5 are here, when there is no potential difference, there is no current through it, it is an ineffective resistor. So the answer will still be the same. Okay. The only change will start coming in the problem only when you have more than one resistor. Did you understand? Make sense? So this concept is somewhat similar to the Wheatstone bridge concept which I told you. I told you, no, for a balanced Wheatstone bridge, what will happen? The current through the galvanometer will be 0. Whenever current through any part is 0, any resistor becomes 0, it becomes an ineffective resistor. What is the reason for it? Because the endpoints have the same potential. Okay. So whenever that is there and you're asked to solve a problem based on calculating the equivalent resistance, you need to remove that ineffective resistor and then redraw the circuit. That's what I did in this case. Here, so you can make a note of this point. Those are online, are you able to understand?
Yes, sir.
Sir.
Okay. So just make a note of this and we'll talk with this one today. So next class I'll be starting fourth chapter. That is moving charges and magnetism. You learn it as magnetism. So the only difference between one you learn in your 10th grade and now is going to be. In your 10th grade, you would have seen more of laws, right? And you would have understood how those laws are to be applied to questions, all the theoretical questions. Now we'll have more of problems. for which we need to derive and see how each of them is going to work. Okay. So I'll start that tomorrow. So I hope everything is clear, no?
Yes, sir.
Yeah.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah.
Thank you.